The Mars Climate Orbiter Bishop Investigation Board was established to investigate the failure of the Mars Climate Orbiter mission in 1999, the mission was a joint effort between the National Aeronautics and Space Administration (NASA) and the European Space Agency, which is the ESA. The orbiter was designed to study the Martian atmosphere and climate. However, the mission ended with premature due to a navigation error that led to the orbiter burning up in the Martian atmosphere. The investigation also highlighted organizational and cultural factors that contributed to the mishaps. There were issues related to the oversight and quality control within the project, as well as lack of standardized procedure for unit conversion and verification process. Additionally, there were cultural barriers that hindered effective communication and collaboration between different teams involved in the mission. There are top 3 authoritative reference publications, which is the number 1, NASA, number 2, Space.com, and number 3, the Planetary Society. The number 1, NASA, which is the official website of the NASA, provides detailed information about the Mars Climate Orbiter mishap investigation, including official reports and findings. And number 2, Space.com, a reputable source for space exploration, news, and information. Number 3, the Planetary Society. This organization is dedicated to promoting space exploration and provides valuable insight into the Mars.
Hello people. There are 2 systems of measuring things that are currently used in the world. If you live in United States, this system is called imperial system, and if you live anywhere else in the world, this system would be the metric system. There are obvious differences in these systems, as in metric we use meter, kilometer, centimeter and millimeter to measure length, whereas in imperial, inch, foot, yard, and mile are used for the same purpose. Similarly, while measuring liquids, metric use liter and milliliter, and in imperial we use gallon and pint. People of United States use imperial units, while the rest of the world use metric. This works fine for the most part. But this smooth functioning was disrupted in 1999 when, due to using this imperial system, the National Aeronautics and Space Agency lost a $125 million Mars orbiter. To know how and why that happened, let's get into it. How NASA had lost a Mars orbiter once. In December of 1998, NASA launched a probe to study Martian climate, atmosphere and surface. The probe was supposed to orbit the red planet and send data back to Earth. The main objective was to study the red planet for possible availability of water, and to look for evidence of any past climate change event that might have transformed the red planet from a paradise to a desert as we know it as today. But things didn't go as planned. On September 8, 1999, on that fateful day when NASA tried to put the probe into orbit, the probe lost contact with the Ground Base Operations Unit. After the tragedy, NASA opened an investigation into the matter. On November 10, 1999, the investigation concluded that the probe lost connection due to technical error which occurred because of the way the software that was handling the navigation system of the probe. As it turns out that the software which was created by Lockheed Martin was programmed to read the force in imperial unit of pound, while the other software in the same chain which was created by NASA was programmed to read the force in metric unit of Newton. The difference produced in the final result, caused by using 2 different units of measurement, was significant enough that the probe ended up in a position where it entered the Martian atmosphere and most probably burned down due to friction. Even though the software provided by Lockheed Martin was not up to the mark, as NASA told them they want everything work on the metric system. But in the end, NASA did not blame Lockheed Martin for the fault, as the investigation concluded that even though the software produced a result in non-desired format, but it was also the responsibility of NASA to test everything before launch and make sure everything worked according to the plan. In the end, we can see that all this can be averted if everyone involved in the process would have used the same measurement system, or if NASA had conducted proper tests before going forward with the mission. But, as it stands, we cannot change the past, we can only learn from it. And NASA did exactly that. After that incident, NASA scaled back its proposed programs and redefined its approach towards Mars, and this brings positive results, as we have seen that NASA have successfully sent several rovers on Mars.
Authoritative reference titles and description. From the comment above, Mars Climate Orbiter Mishap Report 2000. This report provides a detailed account of the investigation conducted by the Mishap Investigation Team, which is the MIT, and the findings related to the cause of the failure. It is also include recommendation for improving the management and execution of future missions. Number 2, NASA Lesson Learned Report 2000. This report highlights the lessons learned from the Mars Climate Orbiter mishaps and provides recommendation for improving communication, coordination, and data exchange between NASA and its international partners. And number 3, NASA Mars Programming Planning and Management 2001. This document outlines the changes made to the management and execution of Mars mission. In response to the findings of the Mars Climate Orbiter mishaps investigation, it provides a comprehensive overview of the corrective action taken to prevent similar incidents in the future. Importance of digital signal processing and communication in space technology. Digital signal processing, which is the DSP, and communication play a crucial role in space technology. The integration of DSP and communication in space technology is vital for various aspects such as satellite communication, deep space exploration, remote sensing, navigation, and data transmission. The significance of DSP and communication in space technology can be understood through the following key points. The number 1, satellite communication. Satellite communication is one of the fundamental applications of DSP and communication in space technology. DSP techniques are used to process signals received from satellites, enabling efficient modulation, demodulation, error correction, and data impression. Communication protocols and systems are essential for transmitting data between ground station and satellites, as well as inter-satellite communication. These technologies are critical for various purposes, including weather monitoring, global positioning system, which is the GPS, and telecommunication and broadcast. As a computer engineering student, the Mars Climate Orbiter Mishap Investigation Report is a valuable source of information for future computer engineers like me, as it highlights the importance of attention to detail, effective communication, and the use of standard units in engineering projects. And the importance of attention to detail. One of the main reasons for the Mars Climate Orbiter is the use of incorrect units in the software calculation. The spacecraft navigation software used pounds per square foot (PSF) as the unit for atmospheric pressure, while the ground team used newtons per square meter, which is the N/m raised to 2. This mismatch in unit led to the incorrect calculation inserted to the spacecraft entering Mars atmosphere at the wrong altitude, causing its destruction. As future computer engineer must pay close attention to detail and ensure that their calculations are accurate and consistent throughout the entire project. Thank you very much. My name is Ben Sumcheta from BS Co A 41, and thank you for watching.